don't know what it's like to be an active brain, and I can't make those same statements about the brains creating or not creating a new node of consciousness. Sometimes people describe spirituality, to move finally to the last topic, as a feeling of oneness with the universe, or a universal flow through the mind, a particular mode of thought, its style of thought. In principle, you could get a computer to do that. But people who strike me as spiritual describe spirituality as a physical need or want. My soul thirsteth for God, for the living God, as the book of Psalms says. Can we build a robot with a physical need for a non-physical thing? Maybe, but don't count on it, and forget software. Is it desirable to build intelligent, conscious computers, finally? I think it's desirable to learn as much as we can about every part of the human being. But assembling a complete, conscious, artificial human is a different project. We might easily reach a state someday where we prefer the company of a robot from Walmart's to our next-door neighbors, or roommates, or whatever. But it's sad that in a world where we tend to view such a large proportion of our fellow human beings as useless, we're so hot to build new ones. In a Western world that no longer cares to have children at the replacement rate, we can't wait to make artificial humans. Believe it or not, if we want more complete, fully functional people, we could have them right now, all natural ones. Okay. Consult me afterwards, and I'll let you know how it's done.
Okay, great. I thought Ray was
Thank you.
In David's presentation of both of these concepts of consciousness, and we can debate them both. I think principally he was talking about a form of performance that incorporates emotional intelligence, because emotional intelligence, even though it seems private and we assume that there is someone actually home there experiencing the emotions that are apparently the case, we can't really tell that when we look at someone else. And in fact, all that we can discuss scientifically is objective observation, and science is really a synonym for objectivity, and consciousness is a synonym for subjectivity, and there is an inherent gulf between them. And so some people feel that actual consciousness doesn't exist, since it's not a scientific concept. It's just an illusion, and we shouldn't waste time talking about it. That's not fully satisfactory in my view, because our whole moral and ethical and legal system is based on consciousness. If you cause suffering to some other conscious entity, that's the basis of our legal code and ethical values. Some people ascribe some magical or mystical property to consciousness. There was some element in David's remarks there in terms of talking about a new node of consciousness and how that would suddenly emerge from software. My view is it's an emergent property of a complex system. It's not dependent on substrate, but that is not a scientific view, because there's really no way to talk about or to measure the subjective experience of another entity. We assume that each other are conscious. That's a shared human assumption, but that assumption breaks down when we go outside of shared human experience. The whole debate about animal rights has to do with, are these entities actually conscious? Some people feel that animals are just machines in the old-fashioned sense of that term. There's nobody really home. Some people feel that animals are conscious. I feel that my cat's conscious. Other people don't agree. They probably haven't met my cat, but then the other view is apparent consciousness, an entity that appears to be conscious, and that will require emotional intelligence. And there's several reasons why I feel that we will achieve that in a machine. And that has to do with the acceleration of information technology. And this is something I've studied for several decades. And information technology, not just computation, but in all fields, is basically doubling every year in price, performance, capacity, and bandwidth. We certainly can see that in computation, but we can also see that in other areas, like the resolution of brain scanning in 3D volume is doubling every year. The amount of data we're gathering on the brain is doubling every year. And we're showing that we can actually turn this data into working models and simulations of brain regions There's about 20 regions of the brain that have already been modeled and simulated. And I've actually had a debate with Tommaso Poggio as to whether this is useful, because he kept saying, well, okay, we'll learn how the visual cortex works, but that's really not going to be useful in creating artificial vision systems. And I said, well, when we got these early transformations of the auditory cortex, that actually did help us in speech recognition. It was non-intuitive. We didn't expect it, but when we plugged it into the front-end transformations of our speech recognition, we got a big jump in performance. And they hadn't done that yet in visual modeling of the visual cortex. And I saw him recently, in fact, at AR 50, and he said, you know, you were right about that, because now they're actually getting models, these early models of how the visual cortex works, and that has been helpful in artificial vision systems. I make the case in Chapter 4 of my book that we will have models and simulations of all several hundred regions of the human brain within 20 years, and you have to keep in mind that the progress is exponential, so it's very seductive. It looks like nothing is happening. People dismiss the Genome Project. Now we think it's a mainstream project, but halfway through the project, only 1% of the project had been done. But the amount of genetic data doubled smoothly every year, and the project was done on time. And if you could factor in this exponential pace of progress, I believe we will have models and simulations of these different brain regions. IBM is already modeling a significant slice of the cerebral cortex. And that will give us the templates of intelligence. It will expand the AI toolkit. It will also give us new insights into ourselves. And we'll be able to create machines that have more facile emotional intelligence and that really do have the subtle cues of emotional intelligence, and that will be necessary to passing the Turing test. But that still begets the key question as to whether or not those entities just appear to be conscious and feeling emotion, or whether they really have emotional subjective experiences. David, I think, was giving a sophisticated version of John Searle's Chinese room argument, where I don't have time to explain the whole argument, but for those of you familiar with it, you've got a guy that's just following some rules on a piece of paper, and he's answering questions in Chinese, and John says, well, isn't it ridiculous to think that that system is actually conscious? Or he has a mechanical typewriter which types out answers in Chinese, but it's following complex rules. And the premise seems absurd that system could actually have true understanding and be conscious when it's just following a simple set of rules on a piece of paper. Of course, the sleight of hand in that argument is that these set of rules would be immensely complex, and the whole premise is unrealistic, that such a simple system could, in fact, realistically answer unanticipated questions in Chinese or any language, because basically what the man is doing in the Chinese room in John Searle's argument is passing a Turing test. And that entity would have to be very complex, and in that complexity is a key emergent property. So David says, well, it seems ridiculous to think that software could be conscious, or even, and I'm not sure if which flavor of consciousness he's using there, the true subjectivity or just apparent consciousness. But in either case, it seems absurd that a little software program could display that kind of complexity and self-emergent awareness. But that's because you're thinking of software as you know it today. If, in fact, you have a massively parallel system, as the brain is, with 100 trillion interneural connections, all of which are computing simultaneously, in which, in fact, we can model those interneural connections and neurons, quite realistically. In some cases today, we're still in an early part of that process, but even John Searle agrees that a neuron is basically a machine and can be modeled and simulated. So why can't we do that with a massively parallel system with 100 trillion-fold parallelism? And if that seems ridiculous, that is ridiculous today, but it's not ridiculous with the kind of technology we'll have, with 30 more doublings of price, performance, capacity, and bandwidth of information technology, the kind of technology we'll have around 2030. These massively parallel systems with the complexity of the human brain, which is a moderate level of complexity, because the design of the human brain is in the genome, and the genome has 800 million bytes, but that's uncompressed. There's massive redundancies. ALUs repeated 300,000 times. If you apply lossless compression to the genome, you can reduce it to 30 to 50 million bytes, which is not simple, but it's a level of complexity we can manage.
Ray, the logarithm of your remaining time is 1.
So we'll be able to achieve that level of complexity. We are making exponential progress in reverse engineering the human brain. We'll have systems that have the suppleness of human intelligence. This will not be conventional software as we understand it today. There is a difference in the apparent feel of technology when it achieves that level of parallelism and that level of complexity. And I think we'll achieve that if you consider these exponential progressions. And it still doesn't penetrate the ultimate mystery of how consciousness can emerge, true subjectivity. We assume that each other are conscious, but that assumption breaks down in the case of animals, and we'll have a vigorous debate when we have these machines. But I'll make one point. I'll make a prediction that we will come to believe these machines because they'll be very clever, and they'll get mad at us if we don't believe them, and we won't want that to happen. So, thank you.
Oh, okay. So, David?
Well, thank you for those very eloquent remarks. And I want to say, first of all, many points were raised. The premise of